Hey, what's going on, guys? Comeback again here. Last video we did implement the leaper pieces mode generation logic. So leaper pieces are the kings and the knights, and this time we're gonna be implementing the moves for the slider pieces for rooks, bishops, and queens. So the very first thing to consider, I just would like to invoke the terminal in the card working directory, and oh my god, my mouse is going crazy. Sorry for this, guys. And I just want to type make to compile the sources, and if it compiles I want to run my chess hexadecimal 88 executable file that would be produced there, and here is the output. So let me have a look. Yeah, I still have slightly changed tricky position, so let me just try to restore this back from the last video. So just copy the tricky position FEM and paste this right over in here, save. Okay, so now it should print the valid stuff here. Okay, perfect. And so let's go for implementing our slider piece moves. So the indentation should be right over in here, and here we'll say bishop and queen moves. So we're just keep implementing our move generate move function. So the very first thing to consider, we need to match the appropriate pieces. So I can say if and board indexed by the current square is equal to so yeah, also we need to make this dependent on side basically. So we say if not side, so which means the side is equal to 0, and 0 is, in our case, it's the white pieces to move. So if the side is equal to 0, we have the white pieces to move. In this case we need to match the white pieces. So I'm using the ternary operator here to distinguish this, guys. So board square would be equal to white bishop, the capital, or board indexed by the current square would be equal to white queen. And I just probably need to enclose this within the parentheses to make sure it's evaluated correctly. Okay, so, and also let me provide some indentations within this if condition, so to make it more readable. So okay, if side this, otherwise we want to match our black pieces. Okay, so black queen and black bishop. Okay. And now before anything else, I just need to make sure that we match these pieces correctly. Well, probably the indentation is not the best ever, but we'll probably drop it like this. So print f, and I want to print square to coordinates, which is an array to map the squares to the coordinates, like a2, a4, e4, and so on. And let's take the current square and let's say bishop or queen, and the string format for, yes, just a string here. Yeah. Okay, so let me just run around this again to see if it's gonna work or not. So we are generating move for the white pieces. Okay, so bishop or queen on f3. Okay, we got a queen here, and then we have d2 and e2. So d2 and e2, we got this bishops here. Perfect. Okay, now we need to match. Now we need to match same for the black pieces. So let me just switch decide to move to the black pieces. Okay, we got the e7 for a queen, and we got g7 and a6. Okay, g7 and a6 for bishops. Okay, so this is already quite pretty nicely. So the next thing to consider would be to loop over the move offsets for bishops, and also obviously queens would share this move offsets because queens also does contain the same diagonal moves just like the bishops do. So, well, I really hope you are familiar with the rules, like chess rules, like how every piece moves. So bishop is only moving diagonally, so bishop moves like diagonally like this, and queen moves also diagonally, but also he can moves back and forth like rooks. So I hope this is quite pretty familiar to you already. Okay, so we need to loop over these offsets. How did I loop over king move? Okay, loop over bishop and queen offsets. Okay, so for index equals to 0, index is less than 4. Let me explain why, and index plus plus. Let me just explain why I use this less than 4. That happens because when we have a look at our piece offsets or piece offset arrays, you have this bishop offsets up to 4 offsets, just like those that we used for the pawns, by the way, to remember, like when we were generating the capturing moves for the pawns, we did make use of this sort of a bishop array as well, but now we'll be using this just straight to the point to generate the moves for the queens and for the bishops as well. So let's do it basically. So probably the very first thing to consider would be to initialize the target square again, target square, and I say int to square would be equal to square plus, and I'm using this bishop offsets indexed by index, so just getting this current index, so 15, 17, minus 15, minus 17. And the next thing to consider, we need to loop over attack ray. So attack ray here. So what I mean by saying this, let's assume that here we got a bishop, right? And these are the squares we're supposed to be iterating over until we either hit an opponent's piece and we break out of the loop, and or we hit our own piece, and in that case we will break out of the loop as well, or it would be an empty square optionally. So that's kind of it. So basically I'll need to check this more precisely, but let's just provide the skeleton for our move generation logic for slidable pieces. So I can say like while, and the condition, okay, the condition should be so to make sure that the target square is not a void, so I can say target square and bitwise end with a hexadecimal 88. So it equals to 0, which means the square is on board. So make sure, so this expression makes sure that the target square our piece is moving to is actually on board. Okay, so yeah, we need also, so the very last thing within this loop would be to increment the target square. So increment target square, and we can say 2 square plus equals, and this board offsets indexed by the index. So copy and paste. So to make sure that piece would be moving further on along this attack ray. Okay, so hope it still compiles and runs. Well, it doesn't. So, oh, it's not the target square. Obviously, it's called 2 square. Sorry. So 2 square. Well, maybe it would be a better idea to call it a target square. Well, but I already did this like 2 squares, so let's just drop it. Yeah, giving a nice variable names is an art itself. So yeah, probably it would be a better idea to give it a name over target square. But yeah, probably drop this like this for now. Okay. So now we need to distinguish 3 cases. So if I say if its own piece, and then if its opponent's piece, so opposite color piece, and on empty square. So if it goes to empty square, let's say if steps probably would be better. So if steps into an empty square. So well, this one is the easiest one. So we can say if okay. I also probably we will need to generate. So I just also want to initialize our target piece. So target piece. So int piece would be equal to board indexed by the 2 square. Okay. So we can now say if not piece, which means that the board indexed by the target square is equal to 0. In this case, we have a com move. So remember, like, we need to distinguish this quite moves from the capture moves. So probably we need just to print the move here. Okay, let me just check one little thing. Yeah, it seems to be just fine. So if I can now print my moves here, so square and 2 square. Okay, so I think we can already see some moves out there. Yeah, but now we would be walking through the pieces, which it's not yet time to see this. So yeah, so if it hits the own piece, which means if the piece so we need to distinguish by side as well. So if not side, which means the side to move is white, so ternary operator here, and in this case if piece so for white it would be greater or equals than 1 and less equals than 6, just like in previous videos, just to match the piece encodings. Okay, so greater or equals than 1 and piece is less equals than 6 for white pieces, right? And own piece for black pieces would be less equals than 12 and greater or equals than 7. Now, for those of you who has skipped the previous videos, let me just quickly explain where this 1, 6, 7, and 12 are coming from. So we have a look at our piece encoding right above, right at the top of the source file. We got this indexes representing the piece code. So E0 for an empty square, then we have this 1, 2, 3, 4, 5, 6. So uppercase letters represent the white pieces. So we have this like more equals than 1, less equals than 6, and here we have the black pieces in range from more equals than greater equals than 7, and the last equals then 12, which stands for an index for a black king there. So I hope this is pretty clear now. So we can move on basically. And in this case, we want just simply to break. Okay, and here it's almost the same, but I just need to shift the places here. So when we hit in actual opponent space, we need to make sure that the pieces we're hitting is the opposite color. So from 7 to 12 and from 1 to 6 here. And if I did everything correctly, this should really generate the bishop and queen moves correctly. So anyway, we need to break after, but before after hitting piece. But before actually doing that, we also need to print our move, or later on we would be adding this moves to the move list. But before that, we'll need to encode our moves into integers. But that's the topic of the further videos, obviously. So now hold my breath, try to compile and run this stuff, and to see what kind of moves is supposed to be generated right over in here. So let's go. So the very first, okay, let's actually start with generating a white piece moves. Moves for white pieces. So we need to start with the square of f3. Okay, so f3, here we got this. So g4 and h5. Okay, so queen is going to g4, going to h5, not going off board. Good. So it's not going here, it's not going here, and it's not going here, which is good. So it's not really taking its own pieces, but we also need to make sure that it would take the opponent's piece, and that's the reason why I want to place, let's say, black pawn onto g4. So 1, 2, 3, 4, and to make it on g4, yeah, we have this 3, so I need to say 1 black pawn and 1. Okay, let's make sure. Okay, so now we got this black pawn on g4, and now it should add a move like f3 to g4. Okay, f3 to g4. Yeah, this is it. We got this f3 to g4, so it captures the opponent's piece, which is quite pretty nice. Okay, and the next thing to consider, so we don't have any we need to have a couple of moves for bishops, so even more than a couple of moves basically. Yeah, bishops. So d2 goes to b3 to c1, so it goes to what? Oh, d2, this one goes to, hold on a second, I just can't see what's going on here. Okay, so we start with the d2 and then the e2 bishop. So d2 goes to c1, goes to e3. So d2 bishop, this bishop goes to c1, yeah, which is right, goes to e3, and then it has to go to f4, g5, and h6. D2, e3, f4, g5, and h6, which is right. And now the e2 bishop is going to d1, to f1. Okay, let's have a look. So e2 bishop goes to d1, which is right, goes to f1, and then it has to go to d3, c4, and b5. d3, c4, and b5. Perfect. And hold on a sec, even goes to a6, right, because there is a black bishop to be captured there. But it's not going to f3, which is correct. Yeah, it's not going to f3, right? e2, and yeah, and these are the pawn moves already. Yeah, so it seems like the bishop and queen's moves are being generated quite pretty nicely. Obviously the perf test would reveal the truth regarding this stuff, and I guess that now we can already check the moves for our black pieces. So I just return this tricky position to its initial state. So removing the pawn from g4. Okay, and I also want to switch the side to black pieces to move, and let's see what we got here. So where do we have the bishop? So first would probably generate moves for a queen. So e7 should go e7 e8, e7 f8, and then e7 d6. So e7 e8, c7 d7, e7 d6. Okay, e7 goes to d6. Well, this is correct. c5 d6 going to c5, not capturing own pawn, which is good. Okay, also goes to f8 right over in here, which is right. Shouldn't go to f6. It doesn't. Okay, also goes to d8 right over in here, which is right. Okay, perfect. So next thing would be the g7 bishop, which has to go to f1 and h6, and that's all. So g7 goes to h6 and f8 exactly. So h6 f8, great. And this bishop should have go to, so bishop a6 go into b7 c8 and all this diagonal. So a6 bishop goes to b5 c4 d3 e2 b7 up to b7. Oh, I'm sorry, up to a6. Okay, stops at e2. So here the black bishop captures the white bishops, and the iteration over the attack rate stops. Perfect. Then we go into b7 and c8. We should have go there, so let's check this as well. Oh my god, I lost this. So a6 bishop goes to b7 and goes to c8, which is quite pretty nicely. Okay, so yeah, this is it regarding the bishops, I guess. So now we need to do the same, but for the rooks and for rooks and queens. So we will add both moves to the queens to move them like backwards, forwards, and to the sides like rook does, and the same for the rooks. So I just want to switch back this side to move back to white. Okay, and I also have the number of moves. Oh my god, why did I open the browser? Sorry for this, guys. I also have a number of knights to move, a number of moves for this particular position for the white pieces, probably for the big black pieces as well. Don't remember really, but we'll cover this. I don't know, maybe in this video, maybe in the next one. Well, we'll see. So first, anyway, we need to implement our rooks and queens moves here. So I just grabbed this bishop and queens moves. Okay, and up to here, copy, paste, and now I need to say rook and queen moves. So now we match either white rook or white queen, or black rook or black queen. Okay, the range of indexes is the same because rook offsets has also up to four indexes, for 4 offsets to distinguish to define its moves. So here we need to make use of the rook offsets array, save, and all the rest really should be the same because the logic of capturing pieces and all this stuff is literally the same. Okay, obviously there is a way for optimizing this to kind of all the leapers and all the sliders in one sort of a loop. But I just want to keep the thing simple, so we will better have more code, but it would be easier to understand like what's going on there. So if I did everything correctly, it should already generate the moves for the rooks and some additional moves for queens. So hold my breath, try to compile and run this again, and what we have here. So first let's figure out if the queen moves has been populated. So F3 now goes to G4 H5, G4 H5. So this array was already available. So F3 G4 H5. Now we have starting from here. So F3 goes to F4. Oh my god, why it goes to G3 twice? Hold on a sec, this is so awkward. Okay, F3 goes to F4. It should go to F5. Goes to G3. Has to go to H3 as well. Goes to H4. Oh my god. Something has gone horribly wrong here. Okay guys, sorry, I just need to figure out what's gonna run here. So we match rook or queen. So rook offsets. What can get wrong with the rook offsets? Okay, let me just try to have a look at the rook offsets. Maybe there is something wrong there. I'm really wondering. No, rook offsets 16 minus 16, 1 minus 1, so 16 step ahead, minus 16 step backwards, 1 step forward, step to the right, minus 1 step to the left. Yeah, this should work. Okay guys, so just need to figure out like what's going on here. Okay, so I just realized what the problem. So I didn't check this increment of the 2 square when it loops over the attack rate. Yeah, obviously that's the little trick here. So we need to change this to rook offsets as well. So now it should work correctly. So let's go to our F3 square. So G4 H5, F3 F4 F5 F6. So goes forwards. So F4 F5 F6 captures the knight and breaks. Okay. Then we go G3 H3. So it goes to G3, captures an H3 and breaks, which is okay. Then goes to E3, D3. Goes to E3, goes to D3 and breaks because of own piece there. So it's not really gonna capture in his own piece, which is good. And at this point the moves for white queen are exhausted. So now let's move on to the white rooks. So white rooks, so A1 there. Okay, A1, where is my A1? So it goes to B1, goes to C1, goes to D1, which is good. And now going upwards because there is a piece standing, not going offboard. So we just put a piece here, you should have captured. We'll make this just right at the moment, but before, let me check the moves for the H rooks. So H1, where is my H1? Goes to G1, goes to F1. Okay, goes to G1, goes to F1. Now let me just try to make put a couple of pieces on the first rank. So let's say 1 and say knight, and 1, and here let's say 1 and knight like this. So here is the updated position we got. So now this rook should go only to G1 and break. H1 goes to G1 and break. Here it is, perfect. And this rook, so A1 only has to go to B1 and C1, and that's it. So only goes to B1 to C1 and breaks. Yeah, perfect. So let me just restore the original position, and from now on we can go checking out the black piece moves. So unfortunately black queen is not really going sideways because it's kind of been blocked by its own pieces, so we'll need to alter the position slightly a bit. And so first we'll make first we'll check the rook moves, save. Okay, and you know guys, what I'm doing now is, you know, like 90% of chess programming, you're just trying to figure out if what you've just written actually works correctly or not. So debugging is kind of 90% in the chess engine development. It's not really, doesn't really take that long to write the code, but it really takes really large amount of time to debug this stuff. So A8, we go to B8, C8, D8, and yeah, this is it. And then we have H8. So H8 goes to H7, H6, H5, H4 here, and doesn't capture on H3 because there is the black pawn standing there, and it also should go to the left. So G8, F8, yeah, perfect, just perfect. So let's alter position a bit so to make sure that the black rooks would be capturing white pawns. So let's say one knight 1 and 1 and knight. So here is our updated position. Okay, so now it goes to B8, C8, and drops on C8 because it has just captured the white knight, and that's it. And this black rook is gonna capture on G8 and drop there. So yeah, it goes vertically and then just gets the knight on G8 and drops the loop. So it seems to be working quite pretty nicely. So the very last thing to consider, I just need to give some space to a white queen to make sure it kind of moves it is able to move to the sides. So here, white queen, so let me just give it some space. Okay, so now it has some space, just so we have this on E7, D6, C5, F8 is probably, so D6, C5, yes, it goes diagonally, but also so C7 and B7, okay, goes to D8, F7, where is it, F7, yeah, oh, okay, it goes to F7, good, and then it drops because there is a black piece standing there, then goes to the other side, so D7, C7, B7, okay. And then it drops because there is a black pawn. And also, if I just say here, I would have put some white piece on. So say I would have like white pawn there. It should drop. It should drop now on C7. So E7, yeah, it goes to C7 and drops. Okay, so seems like capturing opponent's pieces and just not capturing its own pieces. Okay, so it really seems like that we did correctly generate the moves for all the pieces so far, but obviously in order to check this move generator dynamically, we'll need to do lots of things along the way, so it's not it would take several videos until the perf test appears here, so we need to do lots of stuff. I will describe what exactly we'll be doing in the next videos within in the end of this one. But before that, let me just again try to grab this tricky position, or I can even not grab in this, but just simply use the variable, so I can use this tricky position. Save. Oh, sorry, tricky position like this. Okay, and I hope so. Probably here should be 48 moves if memory serves me correctly, but obviously let me just try to check this. So chess programming perf test results, this is what we need, and we'll find this on the chess programming wiki here. So perf results, yeah, perfect. And we have the results for the initial position, which is not really that interesting now. I'm sorry. And this is our tricky position. Okay. Kiwi Pete. This is interesting. This how calls probably. Well, I heard that this is called the tricky position. Oh, probably that comes from the tradition of Blue Fever Software, the guy who's released the most outrageous chess engine in C series, more than 80 videos that I'm really fond of. You can have a link for his channel in the featured channel on this chess programming channel. Yeah, probably that he used to call this position tricky. Yeah, and I really like to call this tricky position. Okay, so yeah, we have exactly 48 nodes, assuming that so 48 nodes means like 48 moves, literally, and assuming that white pieces are about to move. So let's count the moves basically, because we did check the moves in separate already. And now let's just try to precisely count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, this is not a move, 42, 43, 44, 45, 46, 47, 48. Okay, perfect. So I just don't really need this debugging stuff there. So I'm just trying to search for that. Where is that? Where that occurs? Yeah, this print statement I used for debugging stuff is no longer needed here. So okay. Yeah, so up to 48 moves for white pieces in this position. I don't really remember how many there should be for black pieces, even though I knew that once a long time ago. But we can assume that if the white piece moves are correct, the black piece moves should be the same, because we did check them separately. Obviously, if there are any bugs are about to occur here in the move generator, we'll know that after the perf test. So now let me explain the further approach within this particular chess engine that we're supposed to take in the next video. So we will also need to create the move list that would be storing all these moves that has been generated during the move generation. So literally all the print statements we have here to output the move to the console would be replaced with the add move function, and the add move function would be taking the argument of a move itself. And the most interesting and most intriguing, at least for me, the most intriguing part here would be how to encode moves into integers, believe it or not. So that's kind of quite pretty interesting topic. So in order to so we could have a structure. So you know, like there are structures in C programming language which are quite interesting data types. Basically we can even use this type def keyword to define a new data type, but that slows down the performance. I don't say significantly, but it slows down the performance slightly bit. And assuming that we're not actually making use of piece lists here, but just looping over the board array instead, it's really good to have moves being encoded within the integers. And this would be obviously a separate video, probably one of the most exciting along this series. So we would be making use of the bitwise operators in order to either to set up or to remove the bits from a current given integer. So we will encode the from square, the to square, so where it comes from, where it's going to. Also we would have been encoding some various flags like capture flag, so whether the move is a capture or not. Also, if this is the pawn start move. What else flags? Yeah, obviously I need to recall my memory. Yeah, some castling flags probably. So some flags that refers the specific move types in chess, which is absolutely essential and would be used within the make move function. That will. So why do we need that? Because when we make, say, when we make a double pawn move, it's not enough just to move the piece from initial square to the target square. We also need to set up an in peasant square to the square that the pawn has jumped over. That has to be distinguished somehow. So that's the reason to have this, say, double pawn move or pawn start flag being available, and so on. And for the captures, we'll need the captures in order to distinguish the quiet moves and the captures, in order to being able to create our quiescent search function that would be calculating the position until the quiet position is reached. So you know, like, it's not gonna capture the pawn with the queen, claiming like, oh, okay, we want a pawn and we are better now. So it will go through the forced lines until the calm position is reached, the quiet position is reached, and then it will calculate the material, and then if we win something, then we will consider, otherwise we'll just drop that line. But again, it's way easier to show and demonstrate and to implement rather than to explain. So see you in the next videos, guys, where we will be doing this stuff I've been just describing. So hope you learned something interesting out of watching this tutorial. Until the next time, and take care.